Yeah, it's funny. I don't know if I'm the right man to talk about this, because this thing about telemetry came up when working at a client site, and I didn't know what it actually meant until I hit a project now where we have a distributed system, and I'm thinking we need something that collects data. What's that called? And that's what I'll be talking about today. So telemetry is basically about collecting and transmitting data about the performance, the usage, and the health of a distributed system. And broadly, you can group that into logs, metrics, and traces, so different types of telemetry data. Logs are familiar to most of us, I think. The only difference here is that if you collect logs from lots of different systems, you would want to have some metadata attached to it, such as the timestamp, the source, a short message, and perhaps other metadata, like which machine did it originate from, or other environment variables. Metrics are high-level aggregations of measurable things, like counting the number of jobs requests processed, or checking resource usage, like CPU or memory, and similar things. The most interesting part of telemetry is traces. So if you have a distributed system where you have a service that handles a request, and as part of handling it, it calls 3 other services, and they all process this request. And finally, when you're done, you send back a response to the client. And out of interest to monitor your system or to identify bottlenecks or errors, the traces give you the ability to track a request through the distributed system and see where it spends time and where errors occur. You can identify the path that they went through. Now, what do you need to set up telemetry for a distributed system? Well, your applications will need to emit the data. That's a starting point. But you'd need a backend somewhere, a central place where you can put all the data, and perhaps a front end to interrogate it, or set up monitoring tools to trigger on specific events and notify some DevOps manager or the developer that introduced a bug that something is wrong. And we don't want to build all of that ourselves, so I set out to check what products are available, and quite early on hit this thing called OpenTelemetry, which is an open source observability framework. It's vendor and tool agnostic, and it comprises a collection of tools, APIs, SDKs, and protocols to standardize everything to do with telemetry. And looking at vendors to see if they support this, the list is growing. It's already large. It seems to be the way to go. It's actually still under development, some parts of it, but they're, I think, filling out the details, and the general concept of the standard, specifically with traces, is, I think, stable by now. And how would we use this from APL? Because looking at the vendors, they typically use the gRPC protocol to collect the data, and we don't have gRPC tools built into Dyalog APL today. But one of the tools that the OpenTelemetry provides for us is a vendor-agnostic implementation of a collector. So it receives, processes, and exports telemetry data to one or more backends, and its receiver supports 3 different forms of this protocol. So either gRPC, which is the native one, if you like, or you can send Protobuf or JSON payloads over HTTP. And the JSON payload over HTTP is certainly something we can do from Dyalog APL. So we set out to build a prototype, proof of concept toolkit to emit telemetry data from APL. And we've implemented these 3 types of telemetry data. So we've got tools for sending metrics, logs, and traces. We run an OTel collector as an agent close to our application, so on the same machine or in a Docker container to keep it really simple. And that collector is simply configured with a YAML file to specify how it wants to receive the data, if it should enrich it by adding some metadata that is found around in its environment, or filter it. So if you get too many data points, you might want to filter it down to not overwhelm the backend. And you can also batch many messages together to increase or make better use of the bandwidth available. The telemetry service front and back end to inspect and collect the data is something that you can pick and choose from all these vendors. For testing and development, there's a really nice dashboard called Aspire Dashboard, which I believe was developed by the Microsoft team for their own testing and development. Also available as a Docker container, so it makes it really nice and easy to explore. Now, I've already covered this, but our prototype is going to use the JSON payload over HTTP to send this to the OTel collector. And I'm hoping to just go through a simple demo. I'm hoping I will suffer less than JD today, and just show you a little bit what that looks like. How do I get... Oh, you see what I see, that's good. So to start off with, as I said, I want to run the OTel collector and the dashboard in a container, so I have a simple Docker Compose script that I can launch. It starts up a couple of containers. You don't need to worry about what it says there, it's not important. It's just running these collectors for us. And then I navigate to the port that it's opened up here on my local host. And this is what the dashboard looks like. So not a lot to see here. There's nothing being collected. It's using a temporary in-memory database. So whatever I send to it will disappear when I shut down the container. Now, in this demo, most of the configuration uses default ports, and on this one, I don't know, can I? Like this? So most of the default configuration is okay to go with. The only thing that I've changed is the export interval, which is related to sending metrics. So I set it to 10 seconds interval. It will just send some metrics. Depending on your application, you might need traces, logs, meters, or all three. So because this is a demo, I'll go through all of them. Starting with a meter, I create an observable gauge, which is just another way of saying I want to send some memory statistics, and well, depending on your front end, that will render in more or less pretty charts. And I've just picked to show the workspace used. I have a callback defined that gives the workspace used using this IBeam, and I just create that as an observable. So going back to my dashboard, if I go to the metrics tab, I now see a demo and a nice graph showing me how much memory I'm using right now. Another example is the logger, so I just add a log entry saying I'm starting the application. Now going to the structured tab here, I see my log message appeared. Nothing fancy, right? Now traces, as I said, the idea is to create a span or a trace spanning the work that you're doing. And in a distributed system, that would often entail you receiving a service call from another process that may have already started the work. So the initial service starts some process and then calls a second or a third service. And to be able to trace and track the entire processing of this request, they send through a context containing an identifier. So if you have a setup like that, the important thing is to collect this ID from the HTTP header or the whatever other means you're using to communicate between services, and use that to follow up on your traces. I start out by just creating a stupid little span here, covering the initialization step of this service, just to show you what a span looks like. So we can see that at that time, the demo application ran through the initialization phase there, and it took 1.84 seconds. There's not a lot more to be said on that one. But if we look at, if we imagine this application is now starting to run the server, and it triggers a handler to handle a request, then in the beginning of the handling, you'll start your span saying, I'm now starting to process this REST API endpoint, or this resource was accessed. And your application might add some log entries that you can see here. So we see that it did some work here, and there's a link to a trace. And that's because the logger logged a message while it was in an active span. So it's during the processing of a trace, a log entry was added. Here I just simulate accessing a database, and while accessing it, I might log a message with some other severity level. So that's just indicated here with a 15 in my code. It's ranging from 1 to 24, where 24 is fatal, and it's up to you to decide how much of that span you want to use. And here I'm running through some calculations, and this was just to show that the metrics here, now that I'm actually running some calculations, we see that the memory used has increased because I created a smaller variable with lots of complex numbers. And I log some message about it being difficult to handle. And as soon as you delete that, that variable, it just drops again. So we can see that the telemetry is immediate-ish, depending on how you configure the refresh rate of your front end and how you configure the collector. So how often should it pass on? Does it batch up log messages or not? For this, yes. For the just for the workspace used, the metrics require it. So I'll just go through to the end here. We've managed to process the request, and we're about to shut down the service. But this is to visualize what it looks like when you have a trace with lots of different API calls or places in your code where you want to measure certain areas. And what it looks like in this dashboard is that you get all these spans spelled out with the time spent on each, and that you can drill into and view specific log entries that were added during that span. So you can navigate back and forth and explore and aggregate on these requests. So if you imagine you have these requests on a distributed system and scaled up, and you have thousands of requests to the same API endpoint, and some of them fail, you can use this sort of dashboard to identify where it's failing. If it's related to hardware, is it a specific node, or is it a specific path through the system that's failing, or is it down to a specific user? Is John Daintree trying to do something? Is that the reason why it's... Sorry, I repeat John Daintree, but put any name you like after John Smith. Right. And that's about it for that demo part. I just wanted to add that when I demoed this earlier in the year in Milan, Stefanos had from APL or SimCorp Italiana had explored this individually and had actually given it a go to serialize the data using Protobuf. And as I had just hired Sandra, I thought that would be a nice exercise to give to. So she's been working on looking at Protobuf and what it is and how you use it. And I'll hand over to her to talk about that. There we go.
Thank you. Feels like this is gonna fall off, so hope it's gonna stay. All right, so Protobuf, what is it? It's a way of encoding, a format for encoding data. So we turn in-memory data to a byte sequence that you can save or send over a network. So just like JSON or XML or CSV or, yeah. It was designed by Google. It's also used in-house internally in Google. They designed it to be fast, simple, and compact. Often, as you already mentioned, often used with gRPC. Yeah. So I think the easiest way to show what it is to compare it with JSON that I assume all of you have used. Have anyone used Protobuf, by the way? Or? One. All right. So this same data as JSON and as Protobuf. So it's just name, ID, and email. The Protobuf byte sequence is at the top here. So I think the first thing you notice is that doesn't mean anything. So you need the original definition to understand what it is, so it's not human readable. Underneath you have a breakdown of the byte sequence. So the first is 10, and that tells us that the field number is 1 and it's of data type 1. So that's the second thing. Oh, it's falling off. So each field has a number, so we never send the field name, so that's one reason why it's more compact. Another is that there is a default value for each field, so it might be that you don't need to encode the data if it's set to a default value. So then it says we have the length 5, and then you have the data. So same thing for the other thing. You have tag, data, tag, data. How does it work? So you define your data in a protofile. So this is your data structure. It's a person, just name, ID, and mail. And then you use the Protobuf compiler, the protoc, that generates code for you, so usually a class. So we just see an example of a Python meta class here. And then you can use that class to encode and parse your data. So when to use it? As I already mentioned, so the main reason is probably that it's compact, it's fast, and it's small. Also because you need the schema to parse it, so it means that the schema has to be up to date, it's consistent, so it's a kind of a documentation as well, which could be a good thing. It's not readable by humans, might be something that you want it to be, so that's a disadvantage. So there are several supported languages, directly supported by Google, third-party implementations, but there is nothing for APL as far as I've seen. So kind of implemented in APL. So yeah, thank you. So also kind of a project for me to learn APL because I started learning this year. So as a beginner, there were, well, honestly, quite a lot of obstacles, which also means there were a lot of learning. I think the main one was the data type. So what you see here are all the data types, or some of the data types that are in Protobuf. And as you can see, a lot of these, we don't have that in APL. So that was interesting for learning how it's represented internally. So demo time. So we're gonna serialize some data from Python and then parse it in APL and then serialize it again. So here's our data that we have defined. So it's just an address book, consists of several people. And then each person is defined over here. So we're gonna add some data. So the first thing is the class compiled by Protobuf to Python. And then we add an address book and we add 2 people. And let's see. So it's been added, and then we just serialize it here, parse from string, and save it to a file. Which is the dialog one for me?
Yeah, the dialog one was this white one. It's all there.
All right. So we read the data here. It looks like this. Let's create an instance of the address book class. So this class is also generated code from Protoc, the Protobuf compiler. And we can use this instance now to parse our data. And here the data is, as JSON as well. So let's just change our data. Let's see, I think this should actually be like this, I guess. So let's change. And then we can just use the instance to serialize it once again. Uh-huh. AB, the test. Oh, it's address book is so from that proto file that we saw in VS Code.
Yeah, let me just back up a couple of steps. So what Sandra went through was showing you the proto file, which was the schema we started out from. She compiled that with the Proto C compiler into Python code. In a Python function, she instantiated it, populated it, serialized it, and then same thing again, use the Proto C compiler, but this is the missing part that you forgot to mention. Run the Proto C compiler and using a plugin written in APL to generate class codes to generate APL classes. Sorry, the question was what's on line 6? And the answer was considerably longer. So what's on line 6 is the class definition of an address book that has been compiled using the Proto C compiler, using a plugin written in APL, which is a roundabout way of doing what Brandon will possibly help us with, of parsing the proto file and then generating APL code based on the definition in the proto file. There's a proto compiler which Protobuf offers with built-in support for a range of languages. APL isn't among them. So they have an extension point to write your own plugin, which it will call and send you a parsed payload, so you can a tokenized payload which you can use to generate your APL code with. Only problem was that it sends the data using Protobuf. So I think the iteration was the first iteration we used Python to generate APL code,
Yeah.
Once
yeah.
we got up to speed, we swapped it out for the APL version. So it's once it was good enough at understanding.
Needed itself to compile.
Yes.
Yeah.
Bootstrap. Right. Did you have anything else?
No, no.
Yeah.